Hello class, I am your teacher in elementary and intermediate algebra. I'm teacher Laarni, and for our first lesson, this is all about exponents. So when you say they're exponent, it has something to do with the base and the power. So if we have an example, the expression a raised to the fourth, a is the base and 4 is the exponent. It means that the base a will be multiplied by itself by 4 times a times a times a times a. So we have there an answer of a raised to the fourth power. Let's go to the rules of exponents. The first rule, we have the product rule. It is stated that when multiplying monomials that have the same base, write the base, I repeat, write the base and add the exponent. You have to add the exponent. So let's have the rule in symbol, that is x raised to the n times x raised to the n. That would be equal to x plus m plus n. Example, x to the fourth times x to the third. So we have there x raised to the fourth plus 3. So the final answer would be x raised to the seventh. Another example, 2 to the third times 2 to the second. So the answer would be 2 raised to the third plus 2. And that we have 2 to the fifth. And what is 2 to the fifth? That means 2 times 2 times 2 times 2 times 2. And we have the answer of 32. Another example, if we have here the expression x raised to the second y times x raised to the third y to the fourth, we now have the answer of x to the fifth y to the fifth. Okay, we have the second rule that we call it the power rule. When raising monomials to powers, we have to multiply the exponent. I repeat, we have to multiply the exponents. So in symbol, x raised to the n raised to the m. And so we shall have an answer of x raised to the m n. Okay, let's have the example. A raised to the second, open and closed, raised to the third. So we now have an answer of a raised to the sixth. That is, 2 times 3 is equal to 6. Another example, that is x to the fourth, y to the third, open and close, raised to the fourth. So the answer would be x raised to the 16. That is, 4 times 4 is 16. And then y raised to the 12. How? That is 3 times 4. We now have an answer of 12. So the final answer would be x to the 16, y to the 12. Next, 3m to the third, n raised to the second, open and close, raised to the third. And so we now have 3 raised to the third. What is 3 raised to the third? That means 3 times 3 times 3. So we have an answer of 27. And then m raised to the third, raised to the third. So we have there an answer of m raised to the 9. N raised to the second raised to the third. We now have an answer of n to the 6, that is 2 times 3. And so our final answer will be 27m raised to the 9, n raised to the 6. That is the power rule. Okay, class, let's proceed to the third rule. That is the quotient rule. To divide monomials that have the same base, write the base and subtract the exponent. I repeat, you are going to subtract the exponent. In symbol form, we have here x raised to the m divided by x raised to the n. We shall have an answer of x raised to the m minus n. Let's have this example. X raised to the 5th divided by x raised to the 2nd. Of course, our base is x. And then we subtract the exponent. 5 minus 2, we have there the answer of 3. So the final answer is x raised to the 3rd, right? Next, what if we have an expression of 3 raised to the 5th divided by 3 raised to the 2nd? Of course, the base is 3, right? And so, 5 minus 2 is 3. So we now have an answer of 3 raised to the 3rd. And what is 3 raised to the 3rd? That means 3 times 3 times 3. We have an answer of 27. The next example, x raised to the 2nd, y to the 5th, divided by x raised to the 1st, y to the 3rd. And so, we concentrate on the x. 2, that is the numerator, minus the denominator of the exponent is 1. So 2 minus 1, we have there x to the 1st, or simply write there x. Y to the 5th divided by y to the 3rd, we now have 5 minus 3 is 2. So y to the 2nd, and the final answer is xy squared. So remember, if it is the quotient rule, we are going to subtract the exponent. Put that in your mind, in your heart. Okay. Next, okay, let's have the fourth rule. That is the zero exponent rule. Any base except 0, if it is raised to the 0 power, is always equal to 1. Example, y raised to the 0 is equal to 1. Another example, 8 raised to the 0 is equal to 1. Or if we have there the expression, quantity 7a raised to the 4th, b to the 3rd, c raised to the negative 0, quantity raised to 0, the answer is always equal to 1. Let's have now the fifth rule, that is on negative exponents. If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. If we have here x raised to the negative m, that is equal to 1 over x raised to the m. So the reciprocal of x is 1 over x. And the negative m there, it turned out to be a positive m. Or if we have here 1 over x raised to the negative m, the reciprocal of 1 over x is x. And so, the negative m will turn out to be a positive m. Or if we have here x over y raised to the negative n, so we take the reciprocal of x over y, that turns out to be y over x raised. This time, the exponent turned out to be a positive n. Let's have this example. If we have here x raised to the negative 3, so the reciprocal of x is 1 over x, right? And then the negative 3 turned out to be a positive 3. So the final answer is 1 over x raised to the third. Another example, x raised to the second power over y raised to the negative 3. So what is the reciprocal of x to the third over y? So it turned out to be y raised to the third over x raised to the 6. Why 6? Because 2 times 3 is 6. And 1 times 3 is 3. So the final answer is y to the third over x to the 6. The last example is negative 4x to the 7, y to the negative 5. We now have an answer of, we retain negative 4x to the 7, while with the negative exponent y raised to the negative 5th, it turned out to be the denominator, that is y to the 5th. So the final answer is negative 4x to the 7 all over y to the 5th. So class, that is our lesson for today. I hope you can answer the modules given to you correctly and accurately. Bye!